All right, here's my second example of a piecewise function I'm going to graph. Piecewise functions don't have to just have 2 pieces. They can have 3 pieces. They could have 12 pieces. Usually, we're only going to do ones that would have 2 or 3 pieces. So I have 3 pieces here. What's missing here, actually, and it just probably got copied off the screen, is that it usually says f of x equals. Okay, and remember, f of x is sort of like saying y. So really, it's like I have 3 different equations here. I have y equals negative x plus 3. That's negative 1x plus 3, really. Y equals 2x minus 1. And y equals negative 3. And this one's only good for x values less than or equal to 0. This one's only good for x values between 0 and 4, and including 4 but not including 0. It's just plain less than on this side, but includes 4 on that side. And this one's good for x values greater than 4. Okay, so I'm going to do 3 tables of values. 1 for each one of those. So here's y equals negative 1x plus 3. I went ahead and put my negative 1 in there so I don't forget it. Then I'm going to do y equals 2x minus 1. And last but not least, y equals negative 3. Okay, so let's do the first one in blue. So on this one, this is for x values less than or equal to 0. So I will include 0 for sure, and then values less than that, negative 1, negative 2, negative 3, and so on. So I could easily just do my table of values by hand, so let's just do that. Negative 1 times 0, I'm plugging in 0. Negative 1 times 0 is 0, plus 3, so this is 3. Negative 1 times negative 1 is positive 1, plus 3 is 4. When I plug in negative 2, I get negative 1 times negative 2, which is 2, plus 3 is 5. And negative 1 times negative 3, which is 3, plus 3 is 6. And again, this whole thing keeps going in that direction. All right, next one. Let's do it in green. And I'm going to wait and put them on the graph at the same time. So this one goes from 0 to 4. 0, 1, 2, 3, 4. Please notice that when you have numbers on both sides like this, it does not keep going in any one direction. It's got 2 boundaries. It's got 0 on the lower side and 4 on the upper side, and it doesn't keep going. Okay, so I'm not going to draw any arrows here, and the part of the graph that I draw with this chart, with this table, is not going to have arrows. It's going to have almost like a segment. It's going to have ends. All right, so why did I put 0 here? It doesn't say include 0. It just says 0 is less than x, okay? Because I have to know where to put my open circle. So I'm going to put an open circle there. All right, so let's do a table of values in the calculator on this one. Table, I'm going to do y equals 2x. I need to learn how to clear my table first. Y equals 2x minus 1. Enter, and this time I'm going to put it on auto, where it just makes the values for me. Okay, so let's see. I want to look at values from 0 to 4, so I keep going down the list. Here they are. When x is 0, y is negative 1. When x is 1, you can't see it there. There we go. When x is 1, y is 1. When x is 2, y is 3. When x is 3, y is 5. When x is 4, y is 7. Okay? Notice this is closed, so I'm not going to say anything special about it because it does include this, so that's a regular point. And finally, that calculator comes in especially handy if you don't remember what kind of line this is. But y equals a number is always a horizontal line. Y equals negative 3 means every point in the galaxy that has a y value of negative 3, or that has a height of negative 3. That's why it's always horizontal. If you forgot that, let's go to the table. Y equals negative 3. starts giving you points, all of them have a y value of -3. Okay, where is this one going to start? It's going to start at 4 and go up. It says x is greater than 4. Now, can x actually be 4? No, because it's not including it. It's not x is greater than or equal to. It's just plain greater than. So I need to put an open circle right here. That's why I need to know what the value of 4 is, because I need to know where to put the open circle. So again, everything's going to be, all the y values are just -3. So -3, -3, -3, -3, -3, keeps going. All right, so I'm ready to graph it. My first equation, I'm going to plot the point 0, 3, -1, 4, -2, 5, -3, 6, and then it keeps going in that direction, so I'm going to put an arrow on that. So that's my first piece. It goes with this one right here. All right, that one right there. Second piece is the one in green here, the one in the middle down at the bottom. We have an open circle at 0, -1. And then we have 1, 1, 2, 3, 3, 5, 4, 7, and again, no arrows, because this is the middle piece. It's got a piece on either side, so it can't keep going or it would overlap them. Another way of looking at that is, because the x here is between two numbers, the graph is going to be between two numbers and it's going to stop on either end. Okay, so that's my second piece. Last piece, this one right here, goes with this table right over here, starts at open circle at 4, -3. 1, 2, 3, 4, 1, 2, 3. And then all the other y values are also -3, and it keeps going in this direction forever. So I put an arrow. And that is my piecewise function.